This lesson is going to just cover the very basics of logs and how to do some mental math with logs and how to manipulate some expressions with using the laws of logs. Okay, so let's try some mental math. If you are posed a problem like this, all right, log base 2 of 32. What is the log base 2 of 32? You need to be able to translate this, or I think the most effective way of answering this question without a calculator or something like that is to realize that what you're really being asked is 2 to the what power will give you 32 as the answer. And so if we pose this, I think we're a little bit, this makes it a little bit easier for us to find the solution that x is equal to 5. All right, and again, log base 3 of 27, 3 to what power? The log is a power. So the exponent of 3, that gives us 27. 3 to what power is equal to 27? All right, so x is equal to 3. Over here, log base 4 of 2, the exponent of 4, that equals 2. The exponent of 4 to what power is equal to 2, so x is equal to 1/2. All right, so being able to move from one form to the other form will be very helpful on a non-calculator sort of question. Let's continue working with some of these basic ideas of logs. So what if I have the log base 10 of 1 over 100? Well, we can do some manipulating. We can ask ourselves, well, what power of 10 will give us 1 over 100? Maybe there's a bunch of ways to approach this problem. I pose one here where we can say, well, 1 over 100 is really 10 to the negative 2 power. So what power of 10 gives you 10 to the negative 2? Well, that's negative 2. Another way to think about it is we could use a log rule here, move the negative 2 to the front. So log base 10 of 10, the exponent of 10 that gives us 10 is just 1. So negative 2 times 1 is negative 2. So there's a bunch of different ways to think your way through this problem. You might try to pause this right now and see if there were, maybe you can think of 2 or 3 different ways that you could have approached the same problem, gotten the same answer. Okay, over here, what exponent, what power of 3 would give us an answer of 1? 3 to what power is 1? The only way we can get 3 and raise it to a power and get 1 is if that power is 0. All right, and we have to start being able to recognize things like this and be able to see the solution fairly quickly. Like log base 2 of 2, we should be able to see that that's 1. The exponent of 2 that gives us 2 is 1. Okay, now there's a rule called the change of base formula, and we're going to go ahead and play around with that a little bit. Some basic things that you need to know when you go to your calculator. If there is no base written, it's automatically assumed that it's base 10. And then if you have a base e, that's the same thing as the natural log. All right, so natural log is just log base e, which is just a number. Okay, so if I have the log of any base, what I can do is I can change that into a different base. If I take the x in the numerator and then the a in the denominator. So for example, if we really wanted to rewrite log base 2 of 32 as a base 10, so what we can do is we can say, well, we'll take the log of 32 on the top, the log of 32 in the numerator, and the log of 2 in the denominator. And we don't have to write the 10, we can just write log of 32 over the log of 2. This could have very easily have been natural log of 32 or the natural log of 2, and would give us exactly the same answer. So let's try another. Let's try it again. So it's log base 3 of 27. I could just write the natural log of 27 over the natural log of 3. And that would give us the same exact answer as log of 27 or log of 3. And again, here, this is just the log of 2 over the log of 4. And that's how you would use the change of base formula. Okay, so let's try it. Let's apply it. So what we can do is we can rewrite this as the natural log of this number in the numerator over the natural log of this base in the denominator. So that's using the change of base formula strictly, but you might think of different ways that you can solve this. We saw this earlier, and so just showing you a different way that you can approach that problem. Again, we've seen this one before. We could have translated this as the log of natural log of, no, this should be natural, this is upside down. This should be natural log of 1 over natural log of 3. So this is actually not correct. And over here we've got the log of 2 over the log of 2, which is another way of saying, oh, that simplifies to 1. Okay, so here's a more complete list of a bunch of different applications of log, using logarithms. And so what you might want to do as you go through problems in your textbook, and it calls for some sort of manipulation of the logarithm to simplify it, or the exponent to simplify it. You might want to have a list of these rules next to you so that you can maybe see if there's an application that could be helpful. All right, so a couple right off, the log base a of a to the x, these are the log and the exponential function, these are inverses, so they cancel each other out, so you just get x. Same thing with here, the natural log and e to the x, they're inverses, they cancel each other out. And again, you can rationalize what exponent of a gives you a to the x. Well, x would do that, okay? And we can write this in the other form. We can flip it around, and we could have this exponential and this log, right? And they cancel out. And this exponential function with a log and the exponent, and they cancel each other out. So these are the same. They're just different ways of writing the inverse functions. Okay, and this is just saying, you've seen that before. Over here, if we have the log base, and both of these logs have the same base, but we have two different expressions that we're taking it to, you can just cancel out effectively just cancel out the log base a's by raising both sides to making them the exponent of a base a, right? So we can apply this rule if we were to take this rule here, if we took a to both sides, right? And then we can just simplify it to x equals y. All right, let's try a couple basic problems. So here we want to simplify. If we were asked to solve this equation for x, because both of these are log base 2, we can simply just say x is equal to 3. Again, over here, if we were to solve for x, what exponent of 4 gives us 4? Well, x, if that exponent is 1, then that's would give that result. And then simplifying here, we can use a rule where we do 2. We'll move the 2 out in the front, and then natural log and e, they're inverses of each other, so they just cancel each other out, which makes 1 and not 0. So 2 times 1 is 2. Because there's a little invisible 1 here, right? E to the 1 power. So these cancel out. That leaves that 1 there. So 2 to the 1 equals 2. Over here, we can do a little bit of manipulating. This is the same thing as e to the negative 1. Again, the natural log and e, they cancel each other out, and we just get negative 1. All right, here's the last slide. What we're going to do is we're going to use our expansion rules. If we have a log of something messy like this, and we want to split it up into individual logs. And the reason why you might do that is, like if in calculus you had to derive a function that had a complicated expression like this, it might be easier to break them into smaller logs and take the derivative of each of the smaller logs one at a time. We wouldn't do this since the x and the y are together here. That's a whole nother ball game. But we can practice expanding something like that. These are all multiples. This is a product, so I can split them into 3 smaller logs that are all added to each other. Here we can use the exponent and pass it down to the front. And so now what we've done is we've rewritten it into groups of smaller logs. Okay, over here we know that if we have a fraction, what we can do is we can split the logs into the numerator minus the denominator. Again, we can pass this 1/2 to the front. And what we can't do is we can't go any further. We don't have any rule that says this minus this can be split into something else. We can't even split this 3 to the x, 3x into 3, log of 3 plus log of x and then minus this, because this is one group and we don't have any rule that applies to this. So we go ahead and we should just stop here. We can't go any further. Okay, actually I lied. There's one more slide. So what if we were to do the reverse process? What if we wanted to combine all of this into one log? And you might want to do that because maybe solving an equation, you need to find x. What you want to do is you want to get all these x's together as much as you can. All right, so we can move this 1/2 back up here. We can move that 3 up here. Now these are the sum of 2 logs, so what we can do is just add these 2 arguments and put them in, and multiply them and change them into the product. And so we've combined them into one log. So let's say this log equaled 3. Now we can take and take e to both sides, or 10 to both sides, and actually we can move forward and start solving for x that way. So that's the reason why you might need to have this skill. Anyway, let's condense this into one natural log. So we're going to move this 2 over up to the top here, and this is a difference of 2 logs. We're going to change this into a division problem, so we created something like this. Okay, so that's using sort of the basic log rules, and I hope this made things a lot more clear for you.